In previous lecture we solved sub question 1 and 2 from practice set from exercise 1.3 and main question 2. So today we solve sub question 3. Now see, question is log of x raised to the power x minus cos of x bracket raised to the power cot x. That means in base function is here, in power also function. So we have to solve this by using the log. So write in solution, let y is equals to log x bracket raised to the power x minus cos x bracket raised to the power cot x. So first we write here differentiate with respect to x. Therefore dy by dx is equals to d by dx of log of x bracket raised to the power x minus d by dx of cos x bracket raised to the power cot x. That means we have to find derivative of first term minus derivative of second term, but we don't have formula for such types of functions. So for that we have to consider this first function as u and this second function as v. So we write here, take log of x bracket raised to the power x is equals to u and cos x bracket raised to the power cot x is equals to v. That means differentiating this function means finding derivative of d by dx of log x bracket raised to the power x, that is du by dx, and d by dx of cos x raised to the power cot x is equals to dv by dx. So we have to find du by dx, then dv by dx, or you can substitute in place of at this level as u and this second term as v, then you have differentiate. So we find here du by dx, that is d by dx of log x bracket raised to the power x, and dv by dx means d by dx of cos x bracket raised to the power cot x. So here taking log on both sides, so we write here u is equals to log of x bracket raised to the power x. So when we take log on both sides, we write this as log u is equals to log of log x bracket raised to the power x. So we write this power in multiplication. So write here x into log of log x. Now first we have to find derivative of this first, then we write derivative of v. So differentiate with respect to x. We get derivative of log u as 1 by u into du by dx. Write this u clearly. Then we have to write here product rule for this RHS. First function into derivative of second. So here two functions are given. Outer function is log, inner function is log x. So we write here rule of composite function. So write the derivative of this outer function log, that is 1 upon log x. Then we find derivative of this log x, which is 1 by x, that is first function into derivative of second, plus second function into log of log x, derivative of first. So derivative of x with respect to x is 1. So here in next step this x get cancelled. We write here 1 upon log x into this log of log x into 1 as log of log x. We require du by dx. So write u to right hand side. So du by dx is equals to u into, now replace the value of u at the time of transferring this u to right hand side. Value of u is log x bracket raised to the power x, log x bracket raised to the power x into, so here sign is plus, so write in bracket 1 upon log x plus log of log x. Now we have to find dv by dx. First we find du by dx. Now we have to find this dv by dx. So we write derivative of v. Now v is cos x bracket raised to the power cot x. So taking log on both sides. So right here take log on both sides. So we write here log v is equals to log of cos x raised to the power cot x. Now apply the property. So we write this as cot x into log of cos x. So dy by dx, its derivative we denote by equation number 1. So first we find du by dx, now we find dv by dx. So find derivative first. So right here differentiate with respect to x. So derivative of log v is 1 upon v into dv by dx is equal to, here we have to apply product rule. So first function into derivative of this second function, that is derivative of log is 1 upon cos x, then derivative of cos x is minus sin x into, so first function into derivative of second plus second function into second function is log of cos x into derivative of first function, derivative of cot x is minus cos x square x. So right here this minus sin x upon cos x, which is tan x. So right here cot x into minus tan x, then plus minus minus cos x square x into log of cos x. So this cot x into tan x get cancelled. So we get here minus 1 into minus cos x square x into log of cos x. Now we have to find dv by dx. So we transfer this v to right hand side. So right here dv by dx is equals to v into, in bracket. So you can take minus sign common. So we write here minus v into 1 plus cos x square x into log of cos x. Now substitute the value of v. Value of v is cos x bracket raised to the power cot x. So write minus sign first. Minus sign as it is, cos x raised to the power cot x in bracket 1 plus cos x square x into log of cos x. Now we have to find dy by dx with the help of this du by dx and dv by dx. So right here dy by dx is equals to du by dx minus dv by dx. Now du by dx is log x bracket raised to the power x into 1 upon log x plus log of log x. So here minus minus get plus cos x bracket raised to the power cot x in bracket 1 plus cos x square x into log of cos x. So in this way we find the derivative of given function. Now see sub-question 4. We have to differentiate x raised to the power e raised to the power x plus log of x bracket raised to the power sin x. So we write in solution given function as, let y is equal to x raised to the power e raised to the power x plus log x bracket raised to the power sin x. So we write here, put this first function as u. So write, put u is equal to x raised to the power e raised to the power x and v is equal to this second function as v. So v equals to log x bracket raised to the power sin x. So we differentiate this function y with respect to x. So right here differentiate with respect to x. So derivative of y with respect to x, we write dy by dx is equals to derivative of this first function. So we write this given function as y is equal to u plus v first. So we differentiate this, means we differentiate y equal to u plus v. So we write here dy by dx is equal to du by dx plus dv by dx. That means we have to find derivative of this u with respect to x and derivative of this v with respect to x. We use here addition rule first. So we calculate one by one derivative. So right here take u is equals to x raised to the power e raised to the power x. So taking log on both sides, taking log on both sides. So we write here log u is equals to log of x raised to the power e raised to the power x. So we write this e raised to the power x in multiplication by the property of log. So e raised to the power x into log x. So we have to find du by dx. So differentiate with respect to x. So derivative of log u is 1 by u into du by dx is equals to, so we have to apply here product rule. So first function into derivative of second. So derivative of log x is 1 by x. Then second function into derivative of first. Here derivative of e raised to the power x is e raised to the power x. We require du by dx. So right here du by dx is equal to u into. So here we take e raised to the power x common. So write 1 by x plus log x in bracket. Now replace the value of u. So we write here therefore du by dx is equals to x raised to the power e raised to the power x into e raised to the power x in bracket 1 by x plus log x. So first we find derivative of u with respect to x. Now we find derivative of this v with respect to x. So right here you can denote this as equation number second, this as equation number 1. So take v is equals to log x bracket raised to the power sin x. So again taking log on both sides, taking log on both sides. So we write here log v is equals to log of log x bracket raised to the power sin x. So we write this power in multiplication. So we write here sin x into log of log x. That means while differentiating we have to apply here product rule. So differentiate this function with respect to x. So derivative of log v is 1 by v into dv by dx is equal to, here we have to apply product rule. First function is sin x, second function is log of log x. So right here first function into derivative of second. So here this log is composite function, outer function is log, inner function is log x. So find derivative of outer function. So we get 1 upon log x into derivative of inner function, that is derivative of log x is 1 by x. So first function into derivative of second plus second function into log of log x into derivative of first. So derivative of sin x is cos x. So write this as sin x upon x log x plus cos x into log of log x. Now we have to find dv by dx. This is value of 1 by v into dv by dx. 1 by v into dv by dx. So we transfer this v to right hand side. So right here dv by dx is equal to v in bracket sin x upon x log x plus cos x into log of log x. So we write this value. Here we transfer to right hand side. Now we have to substitute the value of v. Value of v is log x raised to the power sin x. So right here in place of v, log x raised to the power sin x in bracket sin x upon x log x plus cos x into log of log x. Now we have value of du by dx. We have value of du by dx. So from equation 1, 2 and 3 we write here, therefore from equation 1, 2 and 3 we replace the value of du by dx, which is x raised to the power e raised to the power x into e raised to the power x in bracket 1 by x plus log x. dv by dx plus dv by dx is log x bracket raised to the power sin x into sin x upon x log x plus cos x into log of log x. So in this way we find derivative of given function. Now see subquestion 5th. Here e raised to the power 10x plus log x raised to the power 10x. Now this is composite function e raised to the power 10x. So we don't have need to take log for first term. Here in base log x in power 10x, that means in base variable function is given, in power also variable function is given. Here logarithmic function, here trigonometric function. So this is of the form f of x raised to the power g of x. So we have to take substitution for second term only. So write in solution, let y is equals to e raised to the power 10x plus log x raised to the power 10x. So we write here derivative of this as dy by dx is equals to derivative of first term plus derivative of second term. So d by dx of e raised to the power 10x plus d by dx of log x raised to the power 10x. So derivative of first term we can find easily with the help of composite function rule. For second we have to take substitution, and taking log we have to differentiate that second term. So we write this as let u is equals to log x raised to the power 10x. So differentiate with respect to x, therefore du by dx is equals to. So we cannot differentiate this function directly. So for that we have to take log on both sides. So you write here taking log on both sides. So we write here log u is equals to log of log x raised to the power 10x. So we write this power in multiplication. So 10x into log of log x. That means here we have to find du by dx. So we cannot differentiate this function directly. So we take log first. So derivative of log u we write here 1 by u into du by dx is equals to, here we have to apply product rule. So first function is 10x. So write 10x into first function into derivative of this second function. So derivative of this outer log is 1 upon log x. Then derivative of this inner function. So derivative of log x is 1 by x. So first function into derivative of second plus second function into, that is log of log x into derivative of 10x. Derivative of 10x is sec square x. So write this as tan x upon x log x plus sec square x into log of log x. Now we have to find du by dx. Here we have value 1 by u into du by dx. So transfer this u to right hand side. So write du by dx is equals to u into. Now replace the value of u, that is log of x raised to the power 10x, and keep RHS as it is. So 10x upon x log x plus sec square x into log of log x. Now we have value of this second term, that is derivative of this second term. So we write here, therefore dy by dx is equals to, so first we find derivative of this first term. So derivative of e raised to the power tan x is e raised to the power tan x, then derivative of this tan x is sec square x, because this is composite function. So we apply first rule for e raised to the power x, then for this tan x, then we write this derivative of log x raised to the power tan x, that is du by dx, which is log x raised to the power tan x into tan x upon x log x plus sec square x into log of log x. So in this way we differentiate the given function. So you have to try question number 6 yourself. So we take question number 8. Sorry, you have to solve question number 6. We take here question number 7. Now 10 raised to the power x raised to the power x plus x raised to the power x raised to the power 10 plus x raised to the power 10 raised to the power x. So we write in solution, let y is equal to 10 raised to the power x raised to the power x plus x raised to the power x raised to the power 10 plus x raised to the power 10 raised to the power x. So we put here first term as u. So put u is equal to 10 raised to the power x raised to the power x. V is equal to x raised to the power x raised to the power 10. W is equal to x raised to the power 10 raised to the power x. We have to find here dy by dx is equal to du by dx plus dv by dx plus dw by dx. That means we find derivative of u, derivative of v and derivative of w separately, and then we substitute that value in equation number 1. So from equation u, so we write here, take u is equal to 10 raised to the power x. So we have to take log on both sides. So write here, taking log on both sides. So write here, log u is equal to log of 10 raised to the power x raised to the power x. So we write this as x raised to the power x into log 10. So we know the derivative of x raised to the power x directly. If you not know the derivative, you have to substitute again in place of x raised to the power x any letter other than u, v, w. So we write derivative of it directly. So differentiate with respect to x. We write derivative of log u as 1 by u into du by dx. This log 10 is constant. So write log 10 as it is into derivative of x raised to the power x is x raised to the power x into, in bracket, 1 plus log x. So if you know, you can write a derivative of this x raised to the power x directly, which is x raised to the power x into 1 plus log x. Now we require du by dx. So write du by dx is equal to, we transfer this u to right hand side and replace the value of u as 10 raised to the power x raised to the power x into log 10 into x raised to the power x into 1 plus log x. Then we find derivative of v with respect to x, that is dv by dx. So right here, take v is equals to x raised to the power x raised to the power 10. So taking log on both sides, we get here log v is equal to log of x raised to the power x raised to the power 10. So using property of log, we write this x raised to the power 10 in multiplication. So x raised to the power 10 into log x. So while differentiating, we have to apply product rule for right hand side. So differentiate with respect to x. Now derivative of log v is 1 upon v into dv by dx is equals to, here we have to apply product rule. So first function into derivative of second, so derivative of log x is 1 by x plus second function, that is log x, into derivative of first. So here we have to apply derivative of x raised to the power n. So we write 10 into x raised to the power 10 minus 1, which is 9. So here x raised to the power 10 upon x, so 1 x get cancelled. So write x raised to the power 9 plus log x plus 10 into x raised to the power 9. So we take x raised to the power 9 common here, and in bracket we write here 1 plus. So here sign is multiplication. So we take x raised to the power 9 common. So here coefficient of x raised to the power 9 is 1. So write plus 10 into log x, because we take x raised to the power 9 common. This is value of 1 by v into dv by dx. We require only dv by dx. Therefore dv by dx is equal to, we transfer v to right hand side. So at the time of transferring, we replace the value of v as x raised to the power, or you can write here v, so you will not confuse. So v into value of v is x raised to the power 10 into x raised to the power 9 into 1 plus 10 log x. Now we have to find dw by dx. W is x raised to the power 10 raised to the power x. So take here, you write this du by dx as equation number second, this dv by dx as equation number third. Then we find dw by dx. Take w is equals to x raised to the power 10 raised to the power x. So taking log on both sides, so we write here log w is equals to log of x raised to the power 10 raised to the power x. So write this 10 raised to the power x in multiplication. So we get 10 raised to the power x into log x. So log w is equals to 10 raised to the power x into log x. Now we have to find derivative of this. So we have to apply product rule for RHS. So write here differentiate with respect to x. So derivative of log w is 1 upon w into dw by dx is equals to, here we have to apply product rule. First function, that is 10 raised to the power x into derivative of log x. Derivative of log x is 1 by x plus second function into derivative of 10 raised to the power x. So 10 raised to the power x derivative is log 10 raised to the power x into log 10. So we find dw by dx. So transfer this w to right hand side. So w in bracket 10 raised to the power x upon x plus log x into 10 raised to the power x into log 10. Now replace the value of w, which is x raised to the power 10 raised to the power x, in bracket 10 raised to the power x upon x plus log x into 10 raised to the power x into log of 10. Now we have value of this du by dx from equation second. We have value of dv by dx from equation number third, and dw by dx from equation number 4. So we write here from equation 1, 2, 3, 1, 2, 3 and 4. So substitute values in equation number 1. So du by dx is from equation second 10 raised to the power x raised to the power x into log 10 into x raised to the power x in bracket 1 plus log x plus dv by dx from equation number 3rd. So x raised to the power 10 into x raised to the power 9 in bracket 1 plus 10 into log x plus derivative of w from equation 4 x raised to the power 10 raised to the power x in bracket 10 raised to the power x upon x plus log x into 10 raised to the power x into log 10. So in this way we find derivative of given function. So here you can take 10 raised to the power x from this last term common. So you can write in next step taking 10 raised to the power x common from this.